Hi everyone, this is Adam again. So in this video I'm going to go over parallelograms, some squares, rectangles, rhombus, polygons, these sort of things, and also parallel lines and triangles. Okay? So first of all, basically how do you identify, so first of all, what's a polygon? So a polygon is basically a shape that has at least three sides. Straight sides. So at least okay. So you could have 3, 4, 5, 6. If you have 10 sides, as long as they're all straight. So something like this. Okay, sorry, that would not. So something like that would be a polygon. This, however, would not be, because one of the sides here is curved. Okay, so this would be a polygon, this isn't. So that's all. The next thing I'm just going to do is basically how do you identify a square as a square, a rectangle as a rectangle, a rhombus is a rhombus, and a parallelogram is a parallelogram. So first of all, a square. So all the sides will be equal. Okay. And it'll have right angles all down here, like this. Okay. Also, sorry, that's a really bad square. Also, the opposite sides are parallel. And if I do the cross section like this, I will get right angles in here. And all of these lengths here will be the same. Okay? So that's basically how you identify a square. How you can say it's definitely a square. You can say if it satisfies all these, it's definitely a square. Okay? For a rectangle, you basically have the exact same things, that the opposite sides have the same length. Okay? But in this case, you don't have all four sides being the same length. So this could be length A and this could be length B, where A is not the same as B. Okay? All of these have to be right angles. So the things in common, rectangles and squares, obviously, of course, they have certain things in common, but basically now we just have that if we do the cross section like this, this is the same length as this, and this is the same length as this. So they're all the same length, and again, the opposite sides are parallel. So for a square, we basically have that all four sides have to be the same. Here we don't have that. Only two sides have to be the same, and they're the opposite sides. And then if we look at the different angles, this angle is going to be the same as this angle. This angle is the same as this angle. But these two angles here don't have to be the same. So they can be the same, and if they are the same, then it's going to be a square. But if they aren't the same, then it's just going to be a rectangle. Okay? And the next thing I'll go over is a rhombus. So a rhombus will look like this. So a rhombus is just like a square. So all the sides are the same. They're all the same length. This angle, so first of all, these sides are parallel. And this side is parallel here. So the opposite sides are parallel. This angle is the same as this angle. This angle is the same as this angle. Okay? And if I do the cross section of it, so again, the cross section of a parallelogram would basically mean that these are all at right angles to each other. Okay? This angle is bisected. This angle is bisected. This angle is also bisected, and so is this one. So that's another important thing, that if you do the cross section, you will get that they are bisected. The same thing up here with the square. These angles have all been bisected, and what does bisected mean? It basically means it's cut in half. So all those angles there that I put a dot beside are 45 degrees, so it's just half of 90. Okay? And now, for a parallelogram, now basically you have that this angle is the same as this angle, this angle is the same as this angle, this side is parallel to this side is parallel to this side is the same length as this, and this side is the same length as this. Okay? And again, if we look at the cross section, what do we get? We basically get that this line has been bisected, so these two are the same length. These two are also the same length. Sorry, back here, I meant to put that this length is the same as this, and this is the same as this. So in the rhombus and the parallelogram is the same. And then this angle is the same as this angle, and this angle is the same as that angle. Okay? So that's basically a parallelogram. All right? And that's how you decide. Another thing to know is that a square is a rectangle, a square is a rhombus, and a square is a parallelogram. A rectangle is a parallelogram. A rhombus is a parallelogram. A rectangle is not a rhombus, and a rhombus is not a rectangle. Okay? So those are the things that you can be asked, because that'll be when the converse kind of comes into it. They might say, what's the converse of this statement? A rectangle is a parallelogram. The converse of that is a parallelogram is a rectangle. And they might ask you, is this true? And the answer is no. So the idea is that a square is very strict because it has to be all the same sides, all the same angles. And then a parallelogram a rhombus is basically like, oh, the angles don't have to be the same. So the lengths have to be the same, but the angles don't. So your angles can kind of like shift. You can start like moving your square from left to right kind of. If the bottom is stuck, you can kind of push it left or right and it'll move left and right. That's kind of what's going on. Okay? All right, let's do a couple of questions. So one might be something like this. So this here is a parallelogram, okay? So we have this, there's this line, and there is this line. So this here is 80. This is A. This is 20. This is D. This is B. And this is 130. Okay? And basically it's just solve for all the different angles. So the very first thing I'm going to do is I'm going to figure out what this angle down here is. This angle has to be 30. Because if I add the three of these up, I need to get 180. So 130 plus 20 is 150. 180 minus 150 is 30. So I'm left with just 30 like that. Okay? The next thing to look at is I'm going to figure out what the angle D is, because I just have a triangle here. Okay? And so I'll have that the angles inside have to add up to 180. So 80 plus 30 plus D is 180. So D has to be 70 degrees. Okay? All right, so hopefully that's all okay. Now remember, this is a parallelogram, so I can always go back up to the parallelogram one and see that, oh, okay, so if I do a cross section, basically the lengths are the same. Okay? So this length is the same as this length. But unfortunately, that doesn't help me. What does help me is that this is 80. So at least we know that. Now, remember, this angle here, this is parallel to this. And so now we're going to use our corresponding angles. So remember your F. So the F is here, which means this angle, 20 and 30, is equal to this angle here. So it has to be 50. And then I can say, well, I know that D plus B plus 50 has to be 180. And since D is 70, I get B plus 120 is 180. So B has to be 60. So we have D is 70, B is 60. So B is 60, perfect. So how am I going to figure out what the rest of them are? So okay, yes, so this is a straight side. So this angle here has to be 100 because the 100 and the 80. Okay, so whether you look at this straight side or this one, both will give you 100 here. So I can figure out what A is from that, okay? So A plus 100 plus 20 it has to be 180, so A has to be 60. Okay? All right, and then figuring out what C is, I can figure out what this angle is because remember from a parallelogram, the opposite angles are the same. Which means this angle plus A has to be equal to B plus D. And B plus D, or even easier, here's a Z. Because remember, this is parallel to this. And therefore A plus the angle, let's say I call it X for the minute, has to equal 130. So A is 60 plus X has to be 130. So X is going to be 70 degrees. And therefore I can figure out what C is because C plus X plus 80 has to be 180 plus 80 equals 180. So C has to be 30 degrees. So that's how you do something like that. Okay. So the next thing that I'd like to do then is basically parallel lines and triangles. Okay. So parallel lines and triangles, basically, you have that if this is parallel, and this is parallel, that if you have a line here and you're told that it cuts it in half, then any other line will also be cut in half. No matter what it is. Okay? So basically the ratio of these numbers will always stay the same. So you'll notice 3 divided by 3 is 1, 4 divided by 4 is 1, and 5 divided by 5 is 1. So the ratio will always stay the same. Okay? And specifically the ratio, you're always dividing. Okay? So basically, what I can do is, if I just do a couple questions, it might be a little bit easier to understand. If I have something like this, okay, and I have a line here and I'm told this is parallel to this, and this is x plus 2, this is 5, this is 5.5, and this is 6.6. Well, then basically what I can say is I can say that this divided by this has to be this divided by this. Okay? So I can say 5 divided by x plus 2 has to be equal to 5.5 divided by 6.6. That's just going to be 5 over 6. If I cross multiply this by this and this by this, I get 30 is going to be 5x plus 10. Divide both sides by 5, I get 6 equals x plus 2. So x is going to be 4. Okay? So yeah, as long as you divide, you're safe. You could also do this divided by this is equal to this divided by this. You could have done either way, okay? As long as you're consistent. If you do bottom divided by top, you have to equal it to bottom divided by a top. You can't switch so I can't do this divided by this is equal to this divided by this. Because if the bottom ones are bigger, then they need to be on the kind of same, they're kind of like similar, if that makes sense. So you have to divide them. If you're dividing one, you have to divide the other as well. Okay. So I'll do another, maybe, yeah, I'll do like another maybe 2 of them, and then I might leave it at that. So basically here you have this, and you're told these 2 things are parallel. This whole distance is y plus 9. This is 4. This is 5.6. And this is 14. So it's 14 from there to there. And it's 5.6 from there to there. So I want to know what y is. So I can say, okay, well, what if I do y plus 9 divided by 4? So what am I doing? I'm doing the whole length divided by the little length. And therefore I need to do the whole length of the top thing, which is going to be 19.6 divided by the length of the small thing, which is 5.6. Okay? So if I do this, I'm going to get that it's y plus 9 is equal to 19.6. So sorry. Yeah. I think I can just divide the bottom by 4. So 1.4, like that. And this actually ends up being 14. I'm pretty sure. So then we get that y equals 5. Okay? So I could have also said, well, this must be y plus 5, because this is 4 and this is y plus 9. So y plus 5 plus 4 is y plus 9. I can do this divided by, this has to be this divided by this. I can do this divided by this is equal to this divided by this. I can do this divided by this equals this divided by this. As long as you keep it consistent, you're always going to be okay. All right. Okay, I'll do one more and then I think I'll leave it there for today. So this one, we have this is parallel to this is parallel to this. So this is 6.5. This is 2.6. This whole thing in here is 9. And this whole thing here is 12. And basically the first thing I want you to do is to find BD. So BD is just this side here. So I'm going to call it X. All right. So now what I'm going to do is I'm going to call this length here Y. And then say this is 12 minus y, and on the bottom I get 9 minus y. Okay? So basically, to figure out so I want to know what x is. To figure out what that is, there's 2 things I don't know. I don't know x and I don't know y, and therefore what I need is I need two equations. So I can do the top thing divided by this is going to be this thing divided by this. So 12 minus y divided by y is going to be 6.5 divided by x. Okay? So I'm going to cross multiply and get actually no, I might just leave it like that for the minute. And then another equation I can do, I can say this divided by this has to equal this divided by this. So y divided by 9 minus y has to equal x divided by 2.6. Okay? So instantly I can say, well, this means that x is going to be 2.6y divided by 9 minus y. And now I can plug that back up into this equation to figure out what y is. So I get 12 minus y divided by y is equal to. Now remember, 1 over x is just this thing flipped. So it's 9 minus y times 6.5 all over 2.6y. So this now simplifies. 1.3 goes into both, I think. So it's just 5 and 2. And I'm just going to cross multiply both sides. So I'm going to get 24y minus 2y squared is equal to, it's going to be 45y minus 5y squared. So I can divide across by y. Okay, no, I'll solve this properly. Sorry, 1 second. So I'll bring this to the left and this to the right. So I'm going to get 3y squared is equal to 21y. So y squared is equal to 7y. The solutions to this are either y equals 0 or y equals 7. I can get rid of the y equals 0 answer because that basically means that this length here just doesn't exist. So I'm assuming that's not the case. And so I can say that y is going to be 7. If y is 7, that means that x is 2.6 times y divided by 9 minus y, which is 2.6 times 7 over 2. That's 1.3, which is 10.1. So x is going to be 10.1 and y is going to be 7. Okay? And the very last one they want to know is, that's easy, so I won't even bother doing that. But yeah, that's how you do these ones. That's how you create these equations. You basically say middle divided by bottom is equal to middle divided by bottom. Top divided by middle is top divided by middle, and so on and so on. Okay, that's how you solve these. Okay, so not too bad once you get the hang of it, but it's definitely worth doing a couple practice questions just to have it under your belt. Okay. All right, I think I'll leave it there for today. So, well, for this video anyways. So thank you very, very much for listening, and I suppose I'll talk to you next one. Bye.